This is Woodruff here. So now that we've done a review of volume and a review of circles, we're going to put those two together today and start our circular volumes with the 3D figure, the cylinder. On the screen here, you can see some examples of cylinders, your soup can, the can holding the nuts here, and some other figures over here. So just to remind what we just did, we've got to remember that the radius in the circle is the distance from the center to the outside of the circle. The diameter is going to be twice that. It's going to go all the way across the circle, and you can see one here going through the center. Remember, that's the diameter. So if you were given the radius for the diameter, you have to double that radius. And if you're given the diameter and you need the radius, you have to cut it in half. Just remember that diameter is the longer word, it's the longer segment. We also talked about the distance around the circle being the circumference, and that's with a capital C, and you can take twice the radius times pi, or we were referring to it as the diameter pi. It's just a little bit shorter. We also talked about the area of the circle being pi r squared. So that was all done sort of in our last lesson, our last worksheet. Don't forget that pi is actually a Greek symbol. It's pi, and it's the ratio of the distance around the circle compared to its diameter. That's what pi is, and it's estimated at usually 3.14. Don't forget there's a pi button on most calculators, all scientific calculators, and you are welcome to use that. That's your most accurate estimation of pi. So today we're going to go on to a cylinder. Now a cylinder is a three-dimensional figure that has two parallel congruent bases that are circles. So I'm kind of circling one here. There's the top of the cylinder, and down here, here's the bottom or the base. Now that base circle would have an area of pi r squared. So if we just took one circle, like one slice out of the cylinder, you could kind of think of it as being a circle, and its area would be pi r squared. Now to get the volume, remember that we need the base area times the height of whatever the figure is. When we talked about prisms and pyramids, we reviewed that. So the base area here is going to be circular. So we're going to take that pi r squared times the height of the cylinder. And you'll notice that's our formula right here. So the pi r squared is the area of the bottom circle times how many circles are in the figure times the height. And that is the volume formula for finding the volume of a can, of a cylinder. So what formula do you use to find the area of the base of the cylinder? It's our area of a circle, pi r squared. Again, we're trying to figure out with volume how much stuff fits in the can. Like, what's the measure of space that's inside the cylinder? So let's do an example here. Here is a cylinder. I'm seeing that this measurement in this red line segment right here goes from the center out to the edge of that top circle. So that would be the radius. So I've been given the radius of 5 centimeters. I've been also given the height of the cylinder, which is 8.3. So I'm going to come over here and I'm going to take my radius and square it. These are the buttons in the calculator. Hopefully you have an x squared on your calculator or some kind of squaring button. So we're going to take that 5 and square it. We're going to multiply it by 8.3, and that number would be 207.5. So 5 squared is 25 times 8.3 would give you 207.5. We still have to multiply by pi, but we're going to stop for a second. And I want you to see that right here. You can kind of see it down here. That is called the exact answer. We have done no rounding and we haven't multiplied by pi yet. That's called the exact answer, and that needs to be in your work for every problem. When you're working with geometric figures, we like to leave that way. It's precise. If somebody was building something, you want the most precise answer. So we don't round yet. Once you've written down your exact answer, then you're welcome to pick up your calculator and multiply that 207.5 times the pi button. If you can't find a pi button, you can use 3.14, but remember that your answers will be slightly smaller than anything that I'm going to be doing with the pi button. If you're using your phone calculator and it has a lot of places, your answer could be slightly bigger. So just realize that depending on what estimation you're using for pi, your answers could be slightly different when you approximate. That's why we like to leave our exact answer as part of our work. So if you take a look at this one, they're not giving us a picture here, but they're telling us that the diameter of the cylinder, so that circle on the top, all the way across through the center measures 16 inches. Now our volume formula needs the radius, not the diameter. Now diameter is the long segment and I need the short one, so I have to cut this 16 in half to get the radius that I'm going to square. So see where the 8 came from was half of the diameter. I'm going to take the radius squared times the height of the cylinder, and I'm going to stop there for a second. So 8 squared is 64 times 20 gives me 1,280, and I haven't multiplied by pi yet. I haven't rounded. This is called my exact answer. So the volume of this cylinder is exactly 1,280 pi cubic inches. Now to estimate it, I'll pick up my calculator and I'll multiply the 1,280 times the pi button or times 3.14, and it's about, notice we've got the wiggly equals here, 4,021.2 inches cubed. So here are two different cylinders, and I would pause the video right now and see if you can find the volume of each of these cylinders. Make sure your exact answer is part of your work, and then in the end, round to the 10th, which means there should be 1 decimal in your final approximate volume answer. Okay, now that we're back, let's see how you did. Remember that volume is going to equal pi r squared, the area of one of those two base circles, times the height of the cylinder. They very nicely gave me the radius, so that 3 is going to substitute in for the r. And the height is 1.8, so I'm going to take 3 squared times 1.8. In my calculator, 3 squared is not 6, guys, it's 9. And 9 times 1.8 is 16.2 pi. And I'm going to stop for a second. That's my exact answer. Now, when I take the 16.2 and multiply by the pi button, or 3.14, it's now going to be an approximate answer, and it's about 50.9 inches cubed. Did you remember to put your units? Did you remember to put to the third power? Now over here, unfortunately, they gave me the diameter, and for the volume of a cylinder, I need the radius. So the diameter is the long segment, so I need to cut it in half to get the radius. So when I go to do my volume formula, you're going to notice I'm going to use a radius of 6 and a height of 5. I substitute those in, and I'm going to take the radius squared, which is 36 times 5, and I'm going to stop before I multiply by pi and write that down. 180 pi is my exact answer. I had an architect that had some kind of cylindrical shape inside of a building or on a bridge. We want to give that architect and that engineer an exact answer, and they'll use as many places as pi they can to get the most accurate number that they could possibly get. But now I am going to estimate it. I'm going to take 180 times pi, and it should be about 565.5 millimeters cubed. So really what we want to see on your paper, we want to see, what are you substituting in? So the line that I'm kind of tracing right here, we want to see that exact answer of 180 pi, and then your approximate answer should only have 1 decimal place rounded correctly, and your units should have cube because volume is that 3-dimensional, as we've talked about, unit. So there's one last problem I want to talk to you about before I let you go to practice on your own. But we can take the volume one step further and get a weight. And the way we do that is we still calculate the volume of the cylinder. And then at the very end, we're going to have to do one more step. And you'll see that in just a second. So we have a metal paperweight in the shape of a cylinder. The paperweight has a height of 1.5 inches, so that's going to be our H in the formula. The diameter, we got to be careful. The diameter is 2 inches. I need the radius, so I'm going to cut that in half, and that's why they're putting a 1 in. And I'm going to calculate the volume. So I'm going to take 1 squared, which is 1, times 1.5, and that's your exact answer. You'll see me typing this over here because your book kind of skips that step, and we need for you to be able to do that as you head into high school math. I'm going to approximate by taking 1.5 times pi, and the volume of this paperweight is about 4.7 inches cubed, but that's not a weight measurement. Inches cubed is not a weight. It's not pounds or ounces or grams, and in this case we want ounces. So once we have that volume, we're going to multiply by the 1.8 ounces per cubic inch. That's called actually a density. You might have talked about that in science. But when you take that volume times its density, you will get the weight. You'll see that little formula over here. So bottom line is you calculate the volume just like we did, and at the end you're going to multiply by what is the weight per cubic unit, and that will give you the weight. And this time it's 8.46, and the weight is in ounces. So your final answer is 8.5 ounces. So let's just try one of those together. The Roberts family uses a container shaped like a cylinder to recycle aluminum cans. It has a height of 4 feet and a diameter of 1.5 feet. The container is full. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot? Round to the nearest tenth. I'm not going to worry about this piece right now. It's a 2-part problem. I'm going to start by finding the volume. Got to be careful. They gave me the diameter. I need the radius, so I'm going to cut that 4 in half. And there is, that's the height. The 4 stays. It's the diameter I'm going to cut in half. So here's my formula. So the radius is half of the 1.5, which is 0.75, and the height is 4. 0.75 is going to be squared times the 4. That's where I'm going to start. And I'm going to get 2.25 pi. I am not going to round to the 10th yet, and I'm not going to multiply by pi. This is my exact answer. Pick up my calculator and multiply by the pi button, and the volume of this container is about 7.068 feet cubed. I'm actually going to leave all the places out right now. I'm going to try to just round at the end. You could leave this on your calculator. And now I'm going to multiply by that 37 to get the ounces, because it's 37 ounces for 1 cubic foot. So now I'm going to take the 37 times my 7.06 cubic feet to find the weight of this. So I multiply that, and you should be getting 261.5 ounces. And notice I round to the 10th at the end. So you find and calculate your volume just like you did, but when you get to the end, there's an added step of multiplying by what's called the density. You don't need to know that, but that 37 ounces per cubic foot, we multiply times the number of cubic feet, and we get the weight, in this case 261.5 ounces. And the idea is of composite solids. We did some of these last year with prisms and pyramids. This year we're going to start to see our round, our circular volumes come into the composite problems. Now, a composite just means that it's more than one shape, and sometimes you're going to have to add the volumes and sometimes you're going to have to subtract. So if it's a hole or something being hollowed out, we're going to take away volume, and if it's sort of a stack with things on top of each other, we're going to add volume. So here's the first problem. You can see that it is a cubed shaped bead, and it has a cylinder drilled through it. So there's a hole here that's in the shape of a cylinder, and we want to find the volume of the bead. So basically we need to find 2 volumes. We need to find the volume of the cube, which is going to be 12 by 12, and since it's a cube, its height would also be 12. And that's what you see happening right down here. 12 times 12 times 12 is 1,728. And that's the volume of the rectangular prism, in this case, the special rectangular prism, the cube. Now we're going to go back. We're going to just pay attention to the hole, which is in the shape of a cylinder. You're going to notice they gave us the diameter. So again, we have to cut that in half to get the radius right there. So 1 squared. We're going to take 1 squared times the height of the cylinder, which is the side of the cube, which remember that height was 12. So we're going to take 1 times 12. So 12 pi would be the exact answer. And then when we multiply it, we get about 37.7 cubic millimeters. To find the volume of the bead, we have to take away the cylinder. Remember, it was drilled out. So we're going to take the volume of the cube minus the hole, minus the cylinder, and the bead would be 1,690.3 millimeters cubed, or cubic millimeters. So this one kind of reminds me of a mailbox in a way. And if you'll notice, we've got two shapes. The bottom shape, again, is a rectangular prism. It's not a cube this time. It's 30 centimeters high, 25 centimeters wide, and 50 centimeters long. So we're going to have to find the volume of that. Now on the top of it is a cylinder cut in half. So it's half of a cylinder. Right here would be its radius of the circle. If that circle kind of came all the way around, you can see this would be the radius. And we're going to have to use this number down here, which goes all the way across, to come up here and figure out what the radius is. And then the cylinder is laying down, kind of like it's sleeping. So the height of the cylinder is actually running along here. It kind of fell over. So you can see that its height would be this 50 centimeters. That this would also be 50 centimeters. So we're going to have to break down the shape. We already talked about there's going to be half of a cylinder sitting on top of a rectangular prism. I like to start with the easier part, so I'm going to find the volume of the box of the rectangular prism, which is length times width times height, and that will equal 37,500 cubic centimeters. So we're going to kind of put that to the side, and we're going to come up here. We're going to look at our cylinder. Remember, we need this right here, this radius, which would be half of the 25. So if this is 25, this is 25, and if we take half of that, that would give us our radius. And don't forget, I mentioned that the height is actually right here. It's laying down, which would be the 50 centimeters. So our volume, we're going to take our volume formula for a cylinder. Our radius is going to be half of the 25, which is 25 divided by 2, 12.5. We're going to square that. And the height of the cylinder, keep your eye on the cylinder right here, is 50. So we're going to start with this formula. We're going to take the radius squared times the height. And it would be 7,812.5 pi would be our exact answer. And if I multiplied it, it's about 24,543.7 if the cylinder had been whole, but we chopped half of it off. So we have to divide this by 2. In the calculator, it's really easy to multiply by 0.5. Dividing by 2 is the same operation as multiplying by 0.5, and that half of a cylinder, kind of like a soup can cut in half, would be 12,271.8 centimeters cubed. Here's the half cylinder. Here's the rectangular prism. Notice they're stacked on each other, so we're going to add those two volumes, and the volume of this composite shape that looks like a mailbox would be 49,771.8 centimeters cubed. Don't forget, you can pause the video if you want to kind of look at this, write this down, see what's going on. Feel free to do that.